Hey Straw Hat Crew, it's been a while since I've made a video. I've been sick for about a month and a half, so if I look like crap, that's why. In this video I'm going to show you how to put together a Mamba build. So let's say you bought a frame but you're wondering how best to lay out the components so everything is nice and neat. Given that the arms are staggered, this is something a little bit new. So in this video I'm going to show you how to lay out your flight controllers, your ESCs, your motor wires, regulators, and battery plugs, all that stuff. So stick around and I'll show you how it's done. Okay, first off, the most important part, the battery wires. So these are AS150 plugs. The housings screw into the TPU print. The TPU print actually has modeled helical threads that these can thread into. And then it has a wide connection going from 10 gauge wire to two 12 gauge wires covered with heat shrink. And then this rear ESC is connected to the top motors, and the front ESC is connected to the bottom motors. The 12 volt 4.5 regulator, which is used to power the cinema camera, it gets its power from the rear ESC, and it takes direct VBAT straight from the battery tabs. This little thing is a capacitor that is soldered to the regulator for extra filtration, and this regulator provides power to this mountable XT60 plug. Now for the flight controller, I decided to mount it up in the front because with the ribbon cables that it came with, they were a little too short, so if I try to mount it in the center, it pulls on the front one here. So having it mounted in the front seems to be working a little bit better. And I got a little lucky because the USB port is not centered, so that means even though the standoff is kind of in the way, I still have plenty of clearance. And then this capacitor does need to be mounted a little bit further back in order to create room for the cable. I soldered a 50 volt 100 microfarad capacitor to the flight controller for extra filtration to give it cleaner power source, and also since I'm using the flight controller to power the DJI Air unit, I want to make sure I don't get any freezes due to voltage spikes caused by the motors. And then of course I've got big ass ESCs for each flight controller. These are 50 volt 1300 microfarads connected with 18 gauge motor wire. And the extension is a little on the long side, but it has never been a problem, even with 6S 2816 1050 kV motors running 9-inch props. So one of them does an S shape to connect to the ESC, and then the other one, if I lift up the flight controller here, it does a C shape to connect to the battery pads of the front ESC. I use liquid electrical tape on the battery terminals of the ESCs because we have a bunch of wire connections here with a big blob of solder, so I just wanted to prevent any debris from causing a short. In addition, these capacitors have some heat shrink stuck on there because they come very close to the two motor signal pads of both ESCs, and I definitely don't want that to cause any issues. A benefit of mounting the flight controller in the front is it avoids the DJI Air unit. You can still have the screws be mounting the flight controller in the center, and they barely don't touch the air unit, but still having it in the front is nice because it gives you some extra factor of safety for clearance. Alright, let's see if we can make sense of this. I have the rear motors mounted to the top half of the drone. This is the top half. The bottom half is over there, not ready yet. So, this is the bottom motor. The bottom motor is going to this ESC, and I have soldered the motor wires to the rear of these ESCs, and same for the other side. So if you follow these wires, this goes to the bottom motor. Now the top motor, which is on the bottom, goes along the side of the arm, around this standoff, and then connects to the rear end of the back ESC. So they're not sharing the same ESC. You do not want to share these motors with the same ESC, because if one of these ESCs goes out, then both of your rear motors are going to go out, and then the drone will go into a death roll. But if you distribute them like this, then if one ESC fails, then only the top set of motors will fail. or the bottom set of motors will fail. And the drone will still fly with 4 motors as long as they're one in each corner. And then talking about wire lengths, so you want to cut the motor wires to the correct length so they can actually reach the pads, but still have enough slack so you're not pulling on anything. So for this motor, which is the top motor going to the rear ESC, I cut each of the wires shorter by about 45 millimeters, and I did it for all 3 wires. I kept them all the same length. Then for the bottom motors going to the front ESC, since it has a bit further to go, I cut off about 20 millimeters worth of wire on all 3 wires. So if you keep it fully at 250 millimeters, it's just excessive amounts of wire, so that's why I cut off just a little bit. Okay, and then the solder joints, it's a little awkward because these standoffs get in the way. So what you got to do is just solder it such that the wire is coming straight down onto the joint, basically. And with these Acon ESCs that are particularly massive, one of the wires I routed a different way than the rest of them because the pad is like right next to the standoff or the screw. And another thing to note is at this point you should not be mounting your capacitors yet, because if we mount it, it will get in the way of these solder pads, which have yet to be soldered. So hold off on that. But I will say that you want to attach the capacitor, give it priority. This goes against the frame, and then the motor wires go over the top of the capacitor. You don't want to run the motor wires underneath the capacitor, especially this one. This one, you can run it over the top just like all the others in order to create a nice flat surface for it to mount against the frame. So after you've soldered your top set of motors, then you can move on to the bottom set of motors. This is how you install the bottom motors. So imagine this is how the drone goes. The way we're going to be disassembling the drone is by flipping it over like that. It's just easier if you only think about it like this. You just flip the bottom plate over like this. Okay, so the first motors we have to work on are not these ones. Let's set these motor wires aside, but rather the bottom motors. What I did is I cut off 45 millimeters worth of wire from each of the 3 motor wires on these motors, these ones. These are actually the bottom motors. It's not flipped this time around because the bottom plate is flipped once again, so it's actually in its normal orientation. But anyway, you just watch what I do. So these wires are connected to this front ESC because remember, this front ESC is connected to the bottom motors, which are attached to the top plate. So this is a bottom motor, that's a bottom motor. It's flipped because we flipped the whole bottom plate upside down. Once you cut off 45 millimeters worth of wire from all 3 strands, then you can solder it to the front ESC, then do it the same for the other side. And then for these motors, you can leave the original 250 millimeters length. If your motors come with longer wire leads, then you can cut it down to 250, but these Brother Hobby motors come stock with 250 millimeters length. And you need that extra length because we're going to be soldering these all the way back here to the rear ESC. If you have any OCD tendencies, look away now. So I finished soldering the bottom plate motors to their respective ESCs. For these solder joints, I made sure to solder them very vertically, coming straight out of the standoffs like this. That's because these wires are going to be redirected toward the bottom plate, so they're actually going to be going like this. And one little tricky part was this capacitor is actually woven between this set of wires and the other set of wires, so you just temporarily move it out of the way in order to access that solder joint. Now at this point I can zip tie the capacitors to the frame. I daisy chained 2 zip ties together and then I ran them through these horizontal portions of the top plate. For the receiver I use extended Immortal T antennas and I plan to put it right there, but it's not quite narrow enough that I can fit it between the 2 trail brackets. So because of this, I got a little piece of foam that came with the packaging for the motors, and I cut a little wedge, and I'm going to use double-sided sticky tape to attach this wedge side to the receiver and then the flat side to that little portion on the carbon fiber. Okay, so that's installed. I threw a little zip tie over the top as well to make it a bit more rigid. And there you can see the bind button is pretty easily accessible. And it's in a good location to have the Immortal T antennas be mounted on each arm. And if you missed it in the frame assembly video, make sure to put some electrical tape down on the carbon fiber before installing the DJI saddle, because we don't want to ground the case of the air unit to the frame. Okay, now when assembling the bottom plate, make sure these DJI wires are somehow secured to the saddle. I might modify the TPU print so there's a little clippy clip, but for now I'm just using a zip tie. And when you flip it over, you should guide the wires so that they're on this side of the standoff. All of the motor wires should be around on this side, just like that. And make sure it's the same way over here, so we got one stray wire. Let's bring that over to the other side. After installing the two halves, it's going to look absolutely heinous, but don't worry. The DJI Air unit, the USB-C is blocked, so we can't update it or activate it. So what you got to do is loosen the saddle, and then you can slide the air unit backward to access via the cable. So this looks pretty awful right here. So you just got to do the same thing you did with the rear arms, step by step, zip tie, zip tie, zip tie, and then stuff the extra wires into the fuselage. And then of course don't forget to actually secure your DJI camera. It's just being held in place with friction as I did the assembly of the bottom plate. And the smaller screws that usually come in the pack are the best bet for working with my universal camera mount.